Hello all, welcome to Unacademy. Today we will going to see our first topic from second topic from complex analysis. Yesterday we have seen how to find out the complex. हमने यहाँ पे Cauchy's CR equations देखे, Cauchy's Riemann equations and we have already seen the Cauchy's Riemann equation yesterday. Now today we will see the complex integration. Okay, so in that integration we will see how to evaluate the complex integral by using the Cauchy's integral formula and by using Cauchy's integral theorem. Okay, so सबसे बड़ी easy technique मैं आपको यहाँ पे बताने जा रही हूँ how to evaluate that complex integration. Okay. See, first going to start this, let me introduce myself. Myself Dhanashree Mam. I completed my MSc in Mathematics from Mumbai University. I'm also having a teaching experience of 13 plus years and I also mentored more than 10,000 plus students for the engineering. Now see, yeah. Now, before going to start this, let me introduce how to install the Unacademy's Learning app. First, go to your mobile's Play Store app and then search Unacademy's Learning app. Then install the Unacademy's Learning app. After that, manage your goal. For which goal you want to study. That is यहाँ पे हम लोग अभी check कर रहे हैं कि गेट एंड ईएससी के लिए पढ़ रहे हैं, तो हमने यहाँ पे गेट एंड ईएससी के लिए मैनेज किया हुआ है. और जो भी आपका कोर्स हो, जैसे भी सब्सक्रिप्शन आप चाहिए चाहते हो, जैसे कि प्लस सब्सक्रिप्शन है, फ्री कोर्सेज है, स्पेशल क्लासेस है, यू कैन चूज एनी वन ऑफ दिस and then press the get subscription button. After that, if you can select your goal here, either you are watching from the either you want to study for the 24 months or for 12 months, accordingly you can see here. And if you want 10% discount on your subscription fees, then you can use my promo code, that is DSP, so that you will get a 10% discount on your subscription fees, which is very important. And you can pay your subscription fees by using any one of this method. Okay, so that's it. Now we will start our actual topic, that is our complex integration. Okay, so how to start that complex integration we will see. Let f of z be a continuous function of the complex variable z is equal to x plus iy defined at all points on the curve C having n points a and b. Divide the curve C into n parts of the points at the points. Okay, here a is equal to p0 z0 p1 z1 p2 z2 and so on pi zi p of r minus 1 into z of r minus 1 up to pn zn. Let delta of zt is equal to zr minus 1 and er be any on the arc pr minus 1 comma pr, then the limit of the summation r varying from 1 to n f of er into delta z raised to r as n tending to infinity and in such a way that delta zr tends to 0 is called the line integral of the function f of z along the curve C. ये तो सिर्फ डेफिनेशन है, आपको कॉम्प्लेक्स इंटीग्रेशन कैसे करना है ये हम लोग देखेंगे कि कौन सी भी लाइन हो. सो अलोंग दैट कर्व, suppose this is your line, then you have to integrate this along this curve C1 to C2, C2 to C3, C3 to Cn up to Cn. So in all, adding all these things, so you will get the total integration of the line. Okay, that is your complex integration here. Now see, and it is denoted by integral over the curve C f of z dz. Now, if the endpoints A and B, now see here, if the endpoints A and B coincide so that C is closed curve, then its integral is called as contour. Okay, suppose this is your closed curve. Now see, what it indicates, see, this is your closed curve, and this is called as a contour. It is not specifically shaped, so this is called as a contour. Okay, this is your contour. If it is uh, given like this, integral over c f of z dz, तो यहाँ पे आ जाएगा आपका ये कर्व, integral over c f of z dz. If the endpoints of a and b coincide, so c is closed curve. Suppose this is your a point and this is your b point, where it closed curve coincides with here, so that curve is called as a contour. Closed curve is called as a contour. Okay, and integral is denoted by, and your integral is denoted by here integral over c f of z dz. Okay, your integral is denoted by closed integral over c f of z dz. Now since z is equal to x plus iy, now see here, since z is equal to x plus iy, then dz is equal to dx plus I dy, and f of z is equal to u of xy plus I v of xy. Then integral over c f of z dz is equal to integral over c u plus iv into dz. Okay, where f of z is equal to u plus iv. Yesterday we have seen w is equal to f of z is equal to u plus iv, and where u and v are functions of x and y. Okay, now here integral over c u plus iv into dz, it means dx plus I dy, because z is equal to x plus iy, right? So you will get dz is equal to dx plus I dy, which is equal to integral over c u dx minus v dy plus I into integral over c v dx plus u dy. Now, very important theorem, that is Cauchy's integral theorem. Okay, if f of z is an analytic function, and f dash of z is continuous at each point within and on a simple closed curve c, then integral over c f of z dz is equal to 0. This is very 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 important. Suppose f of z, मतलब आपका अगर ये curve है, right? This is your curve c. ये आपका कर्व है, और ये आपका f of z जो फंक्शन है, इट इज एनालिटिक विद इन, इसका मतलब है अंदर, दिस इज विद इन एंड ऑन द कर्व सी, मतलब आपका जो भी पॉइंट है कर्व का, जो इनसाइड द कर्व सी लाई हो रहा है और ऑन द कर्व सी लाई हो रहा है, then your integral over c f of z dz is equal to 0. So it is totally depending upon the points which lies inside the curve c or lies outside the curve c. अगर आपका फंक्शन एनालिटिक है ओवर द कर्व सी, जो भी कर्व सी के पॉइंट्स है उसके अंदर वाले जो पॉइंट्स है inside the point c, then the curve then your integral of the f of z dz is equal to 0. Okay, if it lies the curve point c, if it is, then we can find out directly here integral over c f of z dz is equal to 0. अगर आपके point c विद इन एंड ऑन द कर्व सिंपल क्लोज्ड कर्व से, अगर पॉइंट्स आपके जो भी लाई कर रहे हैं कर्व के, वो कर्व के इनसाइड है, अदरवाइज ऑन द कर्व है, मतलब ये कर्व के ऊपर है, राइट? देन योर इंटीग्रल ऑफ द कर्व सी एफ ऑफ जेड डी जेड इज इक्वल टू 0. और एक भी पॉइंट आपका आउटसाइड ऑफ द कर्व सी आ रहा है, सो डेफिनेटली फॉर दैट पॉइंट योर इंटीग्रल वैल्यू इज 0. आ रही है समझ में? Now see Cauchy's integral theorem. If f of z is analytic function and f dash of z is an continuous at each point within on the simple closed curve c, then integral over c f of z dz is equal to 0. Okay. Now see, next is Cauchy's integral formula. Okay. So what is your Cauchy's integral formula? See, the Cauchy's integral formula, if f of z is an analytic within and on the closed curve C, and A is any point within C, then f of A is equal to 1 upon 2 pi I closed integral over C f of z upon z minus A dz. See, here f of z Now see, the f of z is analytic within and on a closed curve C, and A is any point within C, then f of A is equal to, we can say f of A is equal to 1 upon 2 pi I closed integral over C, f of z upon z minus A dz. So here integral over C, f of z upon z minus A dz, here dz, integral over C f of z upon z minus A dz is equal to 2 pi I into f of A. This is very important theorem. See, हम लोग either find out करेंगे complex integration by using Cauchy's integral formula or by using Cauchy's integral theorem. Okay, so by using Cauchy's integral theorem or by using Cauchy's integral formula. So here f of z is analytic within and on a closed curve C, and A is any point within C, then f of A is equal to 1 upon 2 pi I close integral over C f of z upon z minus A dz. Okay, now see here integral over C f of z upon z minus A dz, मतलब A अगर आपका ये काउंटूर है, right? तो यहाँ पे जो भी पॉइंट्स लाई कर रहे हैं, सपोज a1 a2 हम लोग पॉइंट्स लेंगे, अगर ये पॉइंट z इज इक्वल टू a1 a2 ये जो पॉइंट्स है वो लाई कर रहे हैं इन द कर्व सी, सपोज a ये पॉइंट है लाई within and on the closed curve C, and A is any point within C, मतलब ये जो point है A, ये point ये within the curve C है, then the integral over C, then f of A is equal to 1 upon 2 pi I closed integral over C f of z upon z minus A dz, where A Okay. Now see, so here f of z upon z minus A dz, which is equal to 2 pi I into f of A. So you will get here, now suppose if your pole is of order n, okay, suppose pole की order, okay, so see here, if 2 pi I upon n factorial, so आपका अगर ये points है is of order n plus 1 है, okay, then directly we can find out by Cauchy's integral formula, you will get this. Okay, formula is different, theorem is different. So integral over C f of z upon z minus A dz is equal to 2 pi I upon n minus 1 factorial into f raised to n minus 1 at A. So here, how to find out the circle C, z mod of z plus A plus IB is equal to R, gives the circle within a center minus A minus B and radius R. So कैसे निकालते हैं, देखो अगर यहाँ पे हम लोग z is equal to x plus I y डालेंगे, तो ये हो जाएगा plus A plus IB, so ये हो जाएगा mod of, now take the real part, see, real part is this, and plus here is I into y plus b, right? But instead of this, can I write this as the minus of minus A, right, plus I into y minus of minus b. So this is our general form of a circle. So you will get the circle with center at minus A minus b and radius is r. Okay, so mod of z plus A plus IB is equal to r gives you the circle with center at minus A minus b with radius r. Okay, now first example we will see. We will see the many examples here, how to evaluate the integration, how to evaluate the integral by using Cauchy's integral theorem or by using Cauchy's integral formula. Now show that the integration does not depends on the path for the analytic function f of z is equal to 1 by z bounded by the circle C1 such that mod of z is equal to 1 and C2 is equal to mod of z is equal to 2. Okay, so path of the integration is not important here. So we can show that this by using, suppose the first form we will use, instead of using directly that Cauchy's integral formula and Cauchy's integral theorem, I will show you how to evaluate this integral by other method also, is analytic. See, f of z is equal to 1 upon z is analytic everywhere, except, ये कहाँ पे फंक्शन एनालिटिक नहीं है, एक्सेप्ट एट z is equal to 0, right? So therefore we can write here z is equal to r e raised to I theta. अब हम लोग पहले वाला कर्व लेंगे जहाँ पे c1 is equal to mod z is equal to 1 है, तो वहां पे रेडियस ये क्या होगा, c1 is equal to mod z is equal to 1. So mod z है standard circle है, this is a circle with center at 0 0 and radius 1, right? Circle with center at 0 0 and radius 1. Okay, circle with center at 0 0 and radius 1. So you will get here circle with center at 0 0 and radius 1. So here f of z is equal to, you will get f of z is equal to, here put r z is equal to r e raised to I theta. So you will get dz is equal to, now put r is equal to 1. So you will get I e raised to I theta d theta, right? So we can evaluate this integral and theta is limits. So this is a circle, standard circle. So theta is varying from 0 to 1 because this is center with 0 0 and radius 1. So theta is varying from 0 to 2 pi here. Sorry. Theta is varying from 0 to 2 pi. So you will get integral over c f of z dz is equal to integral over from 0 to 2 pi. Now what is your f of z? F of z is 1 upon z, but z is equal to r e raised to I theta, but r is equal to 1. So you will get e raised to I theta here into dz is I e raised to I theta d theta, right? So this will become e raised to I theta, e raised to I theta get cancel out. So you will get I into integral from 0 to 2 pi d theta, which is equal to, I into integral 0 to 2 pi d theta. So which is equal to I into bracket theta from 0 to 2 pi. So it is nothing but 2 pi I, right? So integral of this function is 2 pi I without using any Cauchy's integral theorem or Cauchy's integral formula. But here you can use the Cauchy's integral theorem also, Cauchy's integral formula also. Now if you see, I will prove it by using that theorem also. And see, suppose यहाँ पे आप लोग use करें सी z is a curve given, the contour is a circle with center at 0 0. Okay, this is a circle with center at 0 0 and radius 1. तो ये क्या बन जाएगा हमारा point 1 0. Okay, now see, if you observe here z is equal to 1 up, f of z is equal to 1 upon z. So here z is, here z is equal to z minus a. So a is equal to 0, right? So z is, f of z is analytic everywhere except at z is equal to 0. So z is equal to 0 is a singular point. तो यहाँ पे a is equal to क्या आ जाएगा 0. So you will get f of z integral from, by Cauchy's integral formula, you will get here f of a is equal to integral over C f of z upon z minus a into dz, right? Integral over C f of z upon z minus a into 2 pi I dz is equal to 2 pi I into f of a, right? So here a is equal to 0. So here z is equal to here f of z is equal to here 1. So f of a is equal to 0 will be 1. So you will get your integral of here f of a. So you will get f of a here integral over f of z upon z minus a dz is equal to here 2 pi I into 1, which is again 2 pi I, right? Because a is equal to 0 and here your f of z is equal to only 1. So f of z is equal to 1. So f of 0 is equal to 1. So you will get f 2 pi I into 1, that is 2 pi I. So again you will get the same integral if you do by using the Cauchy's integral formula also. Okay. Now the second one is, what is second one? Again here C2 is equal to mod z is equal to 2. So here C2 is a circle with mod z is equal to 2. C2 is a circle with mod z is equal to 2. So here is z circle. This is a circle with center at 0, 0. This is a circle with center at 0, 0 and radius 2. Right? So this is your point 2, 0, circle with center at 0, 0 and radius 2, right? So C2 is equal to mod z is equal to 2. तो आपका f of z क्या बन जाएगा? यहाँ पे z है आपका r e raised to I theta. So here r is equal to 2 है. So 2 e raised to I theta ये है आपका z. So dz क्या बन जाएगा? 2 I e raised to I theta into d theta. Again theta is varying from 0 to 2 pi. Okay, so your integral, close integral over C f of z dz is equal to integral from 0 to 2 pi f of z is here 2 f of z is equal to 1 upon z. So 1 upon z, z is 2 e raised to I theta into 2 e raised to into 2I e raised to I theta d theta, which is equal to 2 cancel out. So you will get again I into bracket integral 0 to 2 pi. So e raised to I theta d theta. So which is equal to I into bracket integral of e raised to I theta is e raised to I theta upon I into d theta, sorry, from 0 to 2 pi, right? So you will get here e raised to I theta into 0 to 2 pi. So I'm sorry, here is I theta, e raised to I theta, e raised to I theta get cancel out. So only d theta. So you will get here only theta, right? I into bracket theta from 0 to 2 pi. So you will get 2 pi I. So integral over C f of z dz is equal to 2 pi I. Okay. So closed integral over C f of z dz is equal to 2 pi I. So if you observe the same curves, the same function f of z and the curves are different. This is first curve is circle with center at 0, 0 and radius 1, and the second curve is circle with center at 0, 0 and radius 2. Okay. Now see the second one example. Evaluate the integral over C tan z dz where C is the closed contour, mod z is equal to 2. Okay. Evaluate the integral over C tan z dz where C is the closed contour, mod z is equal to 2. So here you will get mod z is equal to 2. So first we will evaluate this integral over C tan z dz, which is equal to, can I write this as sin z upon cos z? So you will get here f of z upon z minus a form. So cos z, right? So dz. Now this is a closed contour C. So if you observe your closed contour C, here I am drawing, this is a circle with center at 0, 0 again because mod z is equal to 2. This is a circle with center at 0, 0 and radius 2. So 2, 0 is the point. This is a circle with center at 0, 0 and radius 2. तो इंटीग्रल ओवर c sin z अपॉन cos z dz. तो ये क्या बन जाएगा, इंटीग्रल ओवर c sin z अपॉन cos z dz. So to find the singularity, we'll put cos z is equal to 0, right? To find the singularity, we put z is equal to cos z is equal to 0, right? So for which values of z cos z is equal to 0? So it will give you z is equal to minus pi by 2, pi by 2, 3 pi by 2 and so on. You will get, so cos z is equal to this. Now this function is analytic within and on the curve c is equal to mod z, except at, why except at z is equal to minus pi by 2 and pi by 2, because these are the 2 points minus pi by 2 and plus pi by 2 which lies inside the curve c, right? So which lies inside the curve c. So we can write here the function is analytic. The function is analytic within the circle, and mod z is equal to 2 except at अभी 3 pi by 2 और ये क्यों नहीं ले रहे हम लोग, because 3 pi by 2 और ये बाहर आ जाएंगे, right? minus 3 pi by 2 है, यहाँ पे plus 3 pi by 2 है. This is outside the circle C because यहाँ पे हमारी radius कितनी दी हुई है, mod z is equal to 2. So यहाँ तक ही है, so ये दोनों points outside the circle C है, right? The function is analytic within the circle except at z is equal to 2, except at z is equal to minus pi by 2 and plus pi by 2, right? So that you will get it here by Cauchy's integral formula. We can say that by Cauchy's integral formula, क्या है formula हमारा, by Cauchy's integral formula we can see close integral over c f of z upon z minus a dz is equal to 2 pi I into f of a. By Cauchy's integral formula, closed integral over c f of z upon z minus a dz is equal to 2 pi I into f of a. Therefore, you will get integral over c. Here sin z upon cos z dz is equal to, now f of z upon this. So you will get integral over c f of z, that is sin z dz is equal to integral over c1, so f of z sin z dz upon cos z dz at here curve c1 plus integral c2, that is sin z upon cos z dz, which is equal to 2 pi I into f of a. f of a क्या है, sin z at z is equal to minus pi by 2 or plus pi by 2 plus into 2 pi I into sin z at z is equal to minus pi by 2. Okay, so 2 pi I into this you will get, so ultimately it will gives you 0 because sin pi by 2, here is minus sin pi by 2 and plus sin pi by 2, so this will gives you 0, right? So ultimately the integral is, value of the integral is 0. Okay? Now see the next one. Evaluate. We are evaluating the integral over c where z minus z square dz, where c is the upper half of the unit circle, mod z is equal to 1. This is very important. See, your function is directly written in the form of z minus z square. It is not in the f of z upon z minus a form. So here at the time we will use a, see here z is the upper half of the circle. It means suppose this is your upper half of the circle, right? So this is our mod z is equal to 1, where upper half of the circle here is x, y, okay. Now this is your closed Cauchy. This is a closed contour, okay. So evaluate this integral. So we can put z is equal to r e raised to I theta, but again here r is equal to 1. So you will get z is equal to e raised to I theta, dz is equal to I e raised to I theta d theta, right? So we will get our, and theta is varying from, now it is upper half part of the circle. So here upper half of the part of the circle, so theta is varying from 0 to pi, okay. Theta is varying from 0 to pi. So here f of z, integral over c f of z dz, so we can integrate this. Integral over c z minus z square dz is equal to, now it is converted into theta is equal to 0 to pi, where z is equal to r e raised to I theta, but r is equal to r is equal to 1. So we can write e raised to I theta minus z square. It means here e raised to I theta bracket square, and dz is equal to I e raised to I theta d theta. Okay, now we will evaluate like this. So integral over c f of, here we are z minus z square into dz is equal to integral, here we can take I outside, and if you see here e raised to I theta into e raised to I theta square, so you will get e raised to I theta minus e raised to e raised to 2I theta. So integral, here you will get I into bracket 0 to pi e raised to I theta minus e raised to 2I theta, right? So this will becomes e raised to I theta and into e raised to I theta d theta, right? So I into bracket, we can check here multiplying by e raised to I theta. So integral from 0 to pi e raised to 2I theta minus e raised to 3I theta into d theta, right? So here you will get integral from I into integral from 0 to pi e raised to 2I theta d theta. So integral from 0 to pi, integral 2I from 2 theta. So I into bracket e raised to 2I theta upon 2I, right? E raised to 2I theta upon 2I minus, here theta is equal to minus e raised to 3I theta upon 3I from 0 to pi, right? Now if I take I common, so here I get cancel out, so you will get here I already cancel out, so you will get e raised to 2I pi, e raised to 2 pi I upon 2 minus e raised to 3 pi I upon 3 minus, here you will get e raised to 0 is 1. So 1 by 2 minus 1 by 3, right? So ultimately you will get here 1 by 2 into bracket 1 by 2 into bracket e raised to 2 pi I. So e raised to 2 pi I, it means cos 2 pi minus plus I sin 2 pi, right? E raised to I theta is equal to cos theta plus I sin theta minus 1 by 3 into bracket, ये बन जाएगा cos 3 pi my plus I sin 3 pi, right? Minus, here is minus 1 by 2 of minus 1 by 3, 3 minus 2, so 1 by 6 minus 1 by 6, right? So in general you will get here 1 by 2 into bracket cos n pi is 1, sin n pi is 0, minus 1 by 3 cos n pi is 1, here minus 1 you will get, because cos n pi is minus 1 raised to n, and if it is equal to minus 1 when n is odd, and plus sin n pi is 0. So you will get here 1 by 2 minus minus plus 1 by 3. So here is 3 plus 1. So we will get here and minus 1 by 6 this. So 5 by 6, 5 by 6 minus 1 by 6, which is equal to 4 by 6, 2 by 3 is the final answer. Okay, 2 by 3 is the final answer. While evaluating this, how to evaluate this integral, we will see. No, evaluate. This is very important. Now see, from actual this example, we will elaborate with the Cauchy's integral theorem and Cauchy's integral formula. Okay, evaluate the integral. First one, अब यहाँ पे कैसे करेंगे? e raised to 2z upon z minus 1 into z minus 2 dz, where c is the circle and mod z is equal to 3. Okay, here mod z is equal to 3. It means the circle with center at 0, 0 and radius 3. So we can directly write down here the function f of z, first one, the function f of z is analytic everywhere, is analytic everywhere within the circle, within the circle mod z is equal to 3. Okay, now we will check whether these 2 points lies inside the curve C or outside the curve C. Okay, the integral has 2 singularities at z is equal to 1. Integral has 2 singularities. Integral has 2 singularities at z is equal to 1 and z is equal to 2. Okay, the integral has 2 singularities at z is equal to 1 and z is equal to 2. So by Cauchy's integral formula, by Cauchy's integral formula, we'll get here integral over C f of z. So here है e raised to 2z upon z minus 1 into z minus 2 dz, right, which is equal to, here we can write this same integral, we can write it here, integral over C e raised to 2z into bracket 1 upon z minus 2 minus 1, a is equal to 1 and b is equal to 2. So here you will get a upon, okay, so here you will get a upon, so 1 upon a minus b into 1 upon z minus a minus 1 upon z minus b. So ultimately you will get here 1 upon a minus b. A minus b, it means here a is equal to 1 and b is equal to 2. So 1 minus 2, that is minus 1. So 1 upon z minus minus 1 into 1 upon z minus 2 minus 1 upon z minus 1. So we adjusted that minus sign and minus sign is absorbed. You are getting this. Okay. So integral over C e raised to 2z upon z minus 1 into z minus 2 dz is equal to, here closed integral over C e raised to 2z upon z minus 2 dz minus integral over C e raised to 2z upon z minus 1 dz, right? So for this f of z upon z minus a dz is equal to 2 pi I into f of a is equal to 2, right, minus 2 pi I into f of 1, right, by 2 pi I into f of 2 minus 2 pi I into f of 1. So here you will get 2 pi I, f of z is equal to your see, why we will write this? Now if you observe the your given curve z is equal to, why we are writing this? Because your curve mod z is equal to 3. So here the points are points of singularity. Z minus 2 is equal to 0, which implies Z is equal to 2. So obviously it lies inside the curve C. Okay, so obviously it is right inside the curve C. So you will get here the curve inside the curve C. So the point lies inside the curve C. Mod Z minus 1 is equal to 0, which implies Z is equal to 1, which is less than 3. So both the points lies inside the curve C. Therefore, by Cauchy's integral formula, we can write here integral over f of 2 pi I into f of 2 minus 2 pi I into f of 1, where here f of Z is equal to here e raised to 2Z. Right? So we can take here f of Z is equal to e raised to 2Z. So we'll get here f of Z is equal to integral over C e raised to 2Z upon Z minus 2 into Z minus 1 is equal to Z minus 1 into Z minus 2 is equal to integral 2 pi I into f of 2 minus 2 pi I into f of 1. 2 pi I into f of 2 minus 2 pi I into f of 1. So here f of 2 is, so e raised to 4. 2 pi I into z is equal to 2. So e raised to 4 minus 2 pi I into z is equal to 1. So you will get 2 pi I into e raised to 1. So e. So I can take 2 pi I common. So you will get e raised to 4 or e square also common. Right? Z is equal to 1. So you will get here 2. So you can take e square common. So 2 pi I into e square. So e square minus 1. So this is your line integral over the curve C, where curve C is given mod Z is equal to 3. Okay. Now we will check for the second one for sine square Z dz upon Z minus pi by 6 raised to 3, where C is the circle mod Z is equal to 1. Now if you observe here mod Z is equal to 1, it means this is a circle with center at 0 0 and radius 1. This is a circle with center at 0 0, we can say here for the curves too. So f of z is equal to sine square z is analytic everywhere within on the curve C, is analytic within C mod z is equal to 1 and having the singularity at point, having singularity at point z is equal to 1 and z is equal to, sorry, at point z is equal to pi by 6. Okay, at point z is equal to pi by 6. Okay, so z is equal to pi by 6, it means here 3.142 by 6, so which is equal to 0.5. Okay, 5 and something. So obviously it is less than 1. So definitely this point which is lies inside the curve C, which lies inside the curve C, which lies inside the curve C. तो यहाँ पे क्या हो जाएगा? If it lies inside the curve C, then which lies inside the curve C. So by Cauchy's integral formula, by Cauchy's integral formula, we get by Cauchy's integral formula we get here by Cauchy's integral formula we get f double dash of a is equal to, because this is a pole of order 3. This is a pole, z is equal to pi by 6 is a pole of order 3. Okay, so we can write here z is equal to pi by 6 is a pole, z is equal to pi by 6 is a pole of order pi by 6. Z is equal to pi by 6 is a pole of order, sorry, is a pole of order 3. Z is equal to pi by 6 is a pole of order 3. Now, so for that we will have a Cauchy's integral formula. इसके लिए Cauchy's integral formula क्या है हमारे पास? For this we have a Cauchy's integral formula. Okay. So we'll get our formula is f raised to n. So you will have here integral over c f of z upon z minus a bracket raised to n plus 1 dz is equal to 2 pi I into f raised to n at a. Right? So here our n plus 1 is equal to 3 है. So n is equal to क्या हो जाएगा 2. So you will get f double dash at 2. So totally your integral becomes integral over c f of z upon f of z क्या है हमारा यहाँ पे sin square z upon z minus pi by 6 cube. So sin square z upon z minus pi by 6, right? Z minus pi by 6 bracket cube dz is equal to 2 pi I upon n plus 1 factorial. Okay, 2 pi I upon n factorial. Pi I upon n factorial into f raised to n at a. Okay. 2 pi I into f raised to n at a into 2 factorial. So you will get this as 2 pi I upon 2 factorial into bracket f double dash at a. So f double dash at a it means क्या होगा d2 by dz square of sin square z at z is equal to a, but a है क्या pi by 6, right? So ये 2 factorial it means 2 cancel out, so you will get only pi I. Now see, first we will find out the derivative of first derivative, that is 2 sin z cos z बन जाएगा ये at z is equal to pi by 6. So derivative of यहाँ पे pi by 6 क्या होगा? So this is derivative of d by dz of 2 sin z cos z. So d by dz of 2 sin z cos z, it means d by dz of 2 sin z cos z sin 2z, easy बन जाएगा. Z is equal to pi by 6. So pi I into bracket d by dz of 2 sin z is cos 2z into 2, right? 2 cos 2z at z is equal to pi by 6. तो ये बन जाएगा pi I into 2 into cos pi by 3, है ना? cos pi by 3, z is equal to pi by 6. तो ये बन जाएगा cos pi by 3, and cos pi by 3 is 1 by 2. cos 61 by 2 होता है. So 1 by 2 और ये 2 cancel out हो जाएगा. So pi I into 2 into 1 by 2. So final answer हमारा आ गया pi I. तो इसका इंटीग्रल क्या हो गया? इंटीग्रल ओवर c sin square z upon z minus pi by 6 z minus pi by 6 raised to 3 dz is equal to pi I. Okay. Now I hope you are clear how to apply the Cauchy's integral formula over here. Now see, evaluate the integral over C mod z dz over the circle mod of z plus 1 is equal to 1. अब यहाँ पे mod of z plus 1 is equal to 1 है. It means z is equal to क्या है यहाँ पे? So we know that z is equal to x plus iy. है ना? Z is equal to x plus iy. So you will get here mod of z plus 1, it means so mod of x plus 1 plus iy. So this is a circle with x minus a and y minus b. तो b 0 है, x minus a तो ये हो जाएगा minus 1 है ना, minus 1 0. This is a circle with center at minus 1 0 and radius is 1. This is a circle with center at minus 1 0 and radius 1. Okay, so ye minus 1, so obviously the curve lies on the curve C. Now we have to evaluate only the mod z. So we know that z is equal to here mod of z plus 1 is equal to 1, right? So z plus 1 is equal to 1. So यहाँ पे r is equal to 1 है, z is equal to r e raised to I theta, है ना? Z is equal to r e raised to I theta. So z plus 1 is equal to here e raised to I theta because r is equal to 1, right? So z plus 1 is equal to e raised to I theta. So which implies z is equal to e raised to I theta minus 1. So you will get dz is equal to I e raised to I theta d theta. Okay, now and theta is varying from 0 to 2 pi. So you will get again mod z. First we will calculate mod z. So mod z is equal to, you will get e raised to z is equal to e raised to I theta. So z is equal to e raised to I theta. It means, can I write cos theta plus I sin theta and minus 1. So take the real part. So cos theta minus 1 plus I sin theta, right? So this is your x and this is your y. So mod of z क्या होगा हमारा x square plus y square, square root of x square plus y square. So cos theta minus 1 bracket square plus sin theta square, right? So mod of z is equal to बन जाएगा square root of, here you will get cos square theta plus sin square theta minus 2 cos theta plus 1, right? But cos square theta plus sin square theta बन जाएगा 1, 1 plus 1 2, 2 into bracket 2 minus 2 cos theta, तो ये क्या बन जाएगा 2 minus 2 cos theta 2 into bracket 1 minus cos theta. So is it nothing but mod z is equal to 2 sin theta by 2, 1 minus cos 2 theta, it means 2 sin square theta. तो 2 sin square theta तो बाहर आ जाएगा, ये हो जाएगा 4 और 4 sin square theta का स्क्वायर रूट हो जाएगा 2 sin theta by 2. So mod z is equal to 2 sin theta by 2. So integral mod z d theta is equal to integral 2 sin theta by 2 into dz है हमारा I e raised to I theta d theta, and theta is varying from 0 to 2 pi. This is a circle. So you will get here integral from 0 to 2 pi I into 2I outside. So integral 0 to 2 pi, right? Integral 0 to 2 pi e raised to I theta into sin theta by 2 d theta, right? So we can apply here integral rule e raised to x into sin dx plus c, right? So ये क्या हो जाएगा 2i into bracket e raised to x, so e raised to x upon a square plus b square, so e raised to I theta upon, यहाँ पे a क्या है हमारा I square is minus 1 plus b square, so 1 by 2 का square 4 बन जाएगा into a cos b, A sin B minus B cos from 0 to pi by 0 to 2 pi. So, okay. तो ये बन जाएगा इंटीग्रल 2i इंटू ब्रैकेट e रेज टू 2 pi I अपॉन cos थीटा इज इक्वल टू, और ये हो जाएगा -4 + 1, सो -3/4, तो ये हो जाएगा 4/-3। तो हम लोग लिखते हैं यहीं पे -3/4 इंटू आई थीटा इज इक्वल टू पाई, सो साइन पाई हो जाएगा यहाँ पे 0, राइट। सो साइन 2 पाई तो बन जाएगा हमारा यहाँ पे 0 और e रेज टू 0, तो साइन 2 e रेज टू 2 पाई थीटा साइन 2 पाई बाय 2, सो ये हो जाएगा साइन पाई, तो ये बन जाएगा साइन पाई आई साइन 2 पाई, आई साइन 2 पाई बाय 2, सो आई साइन पाई -1/2 cos पाई, राइट। तो ये बन जाएगा माइनस 0 पुट करेंगे e रेज टू 0 अपॉन -3/4 I sin 0 -1/2 cos 0, राइट, 0/2 0/2। तो ये हो जाएगा हमारा फाइनल आंसर 2i इंटू ब्रैकेट, अभी e रेज टू 2 पाई i, राइट, e रेज टू 2 पाई i अपॉन -3/2, so sin pi is 0, so this will become 0, right? So 0 minus, now minus of 3/4, तो ये -4/3 हो जाएगा, तो 0 sin 0 0, ये माइनस और ये माइनस प्लस, एंड दिस माइनस अगेन माइनस, तो ये cos 0 1 है, तो ये हो जाएगा -4/3, सो -2/3 -8/3 -8/3, so 2i into -8/3, so -4/3 into this, तो ये हो जाएगा -8i/3, so this is your final answer. Now see, evaluate the curve C e raised to 2z e raised to -2z upon z minus I e raised to z minus I bracket square dz, where C is the square whose vertices are -2 2 -2 2 2 -2 and 2 2. See, C is the square and whose vertices are -2 2. So here Z is the given curve. This curve is analytic. Now we can first draw the curve. Z is equal to 2. Okay, this is your curve. This is the point 2 2. Right? Here you will get a point where -2 2. Here you will get a point where -2 -2. And here is 2 -2. Okay? So ultimately, see here. This is a circle where C is the square, and here is Z is equal to I, right? Z is equal to I is a pole of order 2. Z is equal to I is a pole of order 2. तो यहाँ पे C ये closed curve है, और ये जो point है Z is equal to I is a pole of order 2. So obviously this is a circle with center at क्या आ जाएगा, Z plus 1, so x plus 1 x minus 1, center होगा 1 0, right? Center is 1 0, and radius होगी 1, right? This is a circle with center at 1 0. your curve is situated in this. So totally the line the curve is lies inside the curve C. Now see here, f of z is equal to, what is your f of z? F of z is equal to e raised to minus 2z. So the given curve is analytic everywhere except at z is equal to I. The curve is analytic everywhere except at z is equal to I. Okay, the given curve is analytic everywhere except at z is equal to I, and z is equal to I is a pole of order 2, that is z is equal to I, and z is equal to I lies inside the bounded region, right? It is lie inside the bounded region. Therefore, by Cauchy's integral formula, therefore by Cauchy's integral formula, therefore by Cauchy's integral formula will get, yeah, integral over C f of z upon f of z upon z minus a bracket raised to n plus 1 dz is equal to 2 pi I upon n factorial into f raised to n at a. Okay, so here n is f of z is equal to e raised to minus 2z, f of z is equal to e raised to minus 2z. Then we require f dash of z is also f dash of z is equal to minus 2 e raised to minus 2z, and here a is equal to I, a is equal to I, n plus 1 is equal to 2, so n is equal to 1. So only we required f dash of z. So just put it in the formula. You will get here f of integral over c e raised to minus 2z upon z minus I bracket raised to n plus 1, that is 2, z minus I bracket raised to 2 dz is equal to 2 pi I upon n is equal to 1, that is 1 factorial into f dash at a is equal to I. Okay, f dash at a is equal to I, so you will get e raised to 2I minus 2I, which is equal to 2 pi I, here f dash of I, so instead of z put I, so e raised to minus 2I, so e raised to minus I theta, so you will get here 2 pi I into bracket cos 2 minus I sin 2. Okay, or you can keep as it is also. So this is your Cauchy's integral formula. How to use the Cauchy's integral formula here I'm explaining. Now we will see the next example here. Evaluate the integral over C e raised to 2z upon z plus 1 bracket raised to 4, where C is the contour mod z is equal to 2. मतलब ये C जो कर्व है आपका वो क्या है? C is equal to Z is the curve which is a circle with center at 0, 0 and radius 2. This is a circle with center at 0, 0. Okay. You can draw a circle with center at 0, 0 and radius 2. Okay. This is a circle with center at 0, 0. ये सेंटर है आपका और रेडियस 2 है, तो ये पॉइंट क्या मिलेगा हमें 2, 0. ओके, और ये सेंटर 0, 0 है. So obviously your all the points must lie within and on the curve C. So here if you see, this is a pole of order z is equal to minus 1 is a pole of order 4, and z is equal to minus 1 obviously lies inside the curve C. Okay, the given f of z is equal to e raised to 2z upon the given function e raised to 2z upon z plus 1 bracket raised to 4 is analytic everywhere, is analytic everywhere except except at z is equal to -1 is analytic everywhere except at z is equal to -1. So we have here, therefore -1 is the z is equal to -1 is the singularity of order 4. Okay, so therefore by Cauchy's and which is lies inside the curve C, z is equal to -1 is lies inside the curve C. Z is equal to -1 lies inside the curve C. So you will get here by Cauchy's integral formula, we get what we will get, integral over C f of z upon z minus a bracket raised to n plus 1 dz is equal to 2 pi I upon n factorial into f raised to n at a. Right? So here you will get integral over c e raised to 2z upon z plus 1 bracket raised to 4 dz is equal to 2 pi I upon n factorial. अब यहाँ पे n है 3 because n plus 1 is equal to 4 है, तो 2 pi I upon n factorial into f raised to n. F raised to n, it means f raised to triple dash. Right? Here you will get f raised to triple dash at a is equal to, here z compare with, so f raised to 2z, f dash of z बन गया हमारा यहाँ पे 2 pi I upon 3 factorial into f triple dash at -1. So you will get here 2 pi I upon 3 factorial is 6 into f triple dash at 1. So sorry, first of all we will calculate f dash of z. So 2 e raised to 2z, f double dash of z, 4 e raised to 2z, f triple dash at z, 8 e raised to 2z. Right? So you will get here 8 e raised to 2z. So f of f triple dash at -1 is equal to 8 e raised to -2. So just put it in the formula. So you will get integral over c e raised to 2z upon z plus 1 bracket raised to 4 dz is equal to 2 pi I upon 3 factorial. It means 3 to the 6 into 1. So 2 pi I upon 6 into, यहाँ पे बन जाएगा f ट्रिपल डैश ऑफ -1, तो ये है into 8 e raised to -2. So ये बन जाएगा 4. So 8 pi I e raised to -2 upon 3. Okay, ये हो गया आपका फाइनल आंसर. तो इजी है. हाउ टू इवेलुएट द Cauchy's integral by using Cauchy's integral formula. Now see, evaluate the integral over C. Close integral over C cos pi z square upon z minus 1 into z minus 2 dz, where C is the closed curve, mod z is equal to 3. Okay, where C is the closed curve, mod z is equal to 3. So we can write here the given function f of z is analytic everywhere. The given function, the given f of z is analytic everywhere except at z is equal to 1 and z is equal to 2. Except at z is equal to 1 and z is equal to 2. Okay, and except at z is equal to 1 and z is equal to 2. Now see the curve mod z is equal to c. So both the points, see the curve mod z is equal to c. This is a circle with center at 0 0 and radius 3. So obviously the points 1 and 2 lies inside the curve c. So here you will get, so here you will get mod of z is equal to 3. So definitely the all the points z is equal to 1 and z is equal to 2 lies inside the curve C. So therefore we can use the Cauchy's integral formula here, but before that we will separate out this. So integral over C, so 1 upon z minus 1, z minus 2, so 1 upon z minus a into z minus b हो जाएगा 1 upon a minus b into क्या रहता है हमारा 1 upon z minus 1 into z minus 2, ये बन जाएगा 1 upon a minus b into 1 upon z minus a minus 1 upon z minus b. Okay, so if I observe here minus 1 हो जाएगा, तो ये मैंने माइनस साइन ऑब्जर्व किया तो z minus 2 minus 1 upon z minus 1 बन जाएगा, right? So you will get this. So f of z is 1 upon, so 1 upon z minus 1 into z minus 2 is this. So your Cauchy's integral, we can write here cos pi z square upon z minus 1 into z minus 2 dz is equal to integral over c cos pi z square upon z minus 1 dz plus minus, here separate out this, minus integral over c cos pi z square upon z minus 2 dz. Okay, ये बन गया आपका integral over c cos pi z square upon this. Now evaluate the separate out since z is equal to 1 and z is equal to lies inside the curve c. Z is equal to 1, z is equal to 2 lies inside the curve c. Z is equal to 1 and z is equal to 2 lies inside the curve c. Therefore, by Cauchy's integral formula, we get integral over c f of z upon z minus a dz is equal to 2 pi I into f of a, because here is pole z is equal to 1 and z is equal to 2 is a pole of order 1 only. So we can write here integral over c cos pi z square upon z minus 1 into z minus 2 is equal to here 2 pi I into f of 1 minus 2 pi I into f of 2. 1 second, we'll see. Here is 2 and here is 1 into 2 into 1, right? So here f of z is equal to cos pi z square. So here f of 2 is equal to cos pi 2 square, that is 4, right? So cos 4 pi hmm? And f of 1 is equal to, here f of 1 is equal to cos pi. So ultimately this equation 1 becomes all the values. So integral over c cos pi z square upon z minus 1 into z minus 2 dz is equal to 2 pi I, f of 2 है cos 4 pi minus 2 pi I into cos pi. Okay, cos n pi is, I am taking 2 pi I common, cos n pi is equal to minus 1 raised to n, where n is here even, so you will get 1. Here n is odd, so minus 1. Minus of minus 1 plus 1 बन जाएगा, so which is equal to 4 pi I. I hope you are clear how to evaluate this. Now see, it is purposefully given by using the Cauchy's integral formula. Evaluate the integral over c. Evaluate the integral over c 2z square plus z upon z square minus 1 dz, where c is the circle, mod z of minus 1 is equal to 1. Okay, where c is the circle, mod of z minus 1 is equal to 1. So here we can get mod of C is the circle where mod of z minus 1 is equal to 1. So directly evaluate it. So we will get here is our z. Z is nothing but the so here f of z is 2z square plus z upon z square minus 1. So we can write this as 2z square plus z upon z plus 1 and z minus 1. A plus b, a minus b. So again evaluate. So if the function f of z is analytic everywhere except z is equal to 1 and z is equal to minus 1. The curve f of z is analytic everywhere except z is equal to 1 and z is equal to minus 1. So for this curve, now if you see which curve is inside the curve C, mod of z minus 1. So mod of z minus 1 is equal to 1. So put z is equal to 1. So you will get 1 minus 1 is equal to 0. 0 is less than 1. So z is equal to 1 lies inside C. Lies inside C. Right? And z is equal to minus 1, minus 1, minus 1, which is equal to mod of minus 2 is 2. So which is greater than 1. So z is equal to minus 1 lies outside the curve C. एक पॉइंट कर्व के अंदर है, एक पॉइंट कर्व के बाहर है, right? Lies inside curve C and lies outside curve C. Now see how to evaluate this type of integral. So here z is equal to 1 is a point. Here z is equal to 1 lies point lies inside the curve C. So here f of by Cauchy's integral formula will get by Cauchy's integral formula will get integral over C f of z dz f of z z minus a dz is equal to 2 pi I into f of a, right? But यहाँ पे अगर आप देख रहे हो तो f of z क्या है हमारा 2z square by z 2z square plus z upon यहाँ पे है z square minus 1, but which is the point lies inside the curve C. So z is equal to 1 lies inside the curve C, right? So यहाँ पे जो भी outside the curve C है वो ऊपर चला जाएगा. So z is equal to minus 1 ये outside the curve C है. So the same integral we can write 2z square plus z upon z plus 1. Okay, because z is equal to minus 1 lies outside the curve C upon z minus 1 dz. Now what will be your f of z is here? Here a is equal to 1 and f of z is equal to 2z square plus z upon z plus 1. Right? Now put a is equal to 1. So you will get here ultimately it's a 2 pi I into f of 1. So integral over C 2z square plus z upon z plus 1 into z minus 1 dz is equal to here 2 pi I into f of a is equal to 1. So you will get here f of 1 is equal to 2 plus 1 that is 3 by 2. So here you will get 3 by 2, right, into 3 by 2. So 2 to get cancelled out. So 3 pi I is the value of the closed integral over the curve C where f of z is this, where one of which is lies inside the curve C, one point lies inside the curve C and other point lies outside the curve C. Then how to evaluate this integral? Now, see by using Cauchy's integral formula, evaluate the integral over C, z plus 4 upon z square plus 2z plus 5 dz, where C is the curve. Now the curves are different. C is the curve. Mod of z plus 1 minus I is equal to 2. Okay. Here mod of z plus 1 minus I is equal to 2. So first we will find out here z. Okay, so here z you will get mod of z is equal to x plus iy. So z plus 1 minus I is equal to here x plus iy plus 1 minus I. So which is equal to, you will get x plus 1 and plus I into bracket y minus 1. So this is a circle with center minus 1 1 and radius 2. This is a circle with center minus 1 1 and radius 2. Okay, so we will check whether the given function f of z is analytic or not here. So we will find out first the pole. Okay, so can we write this f of z as z plus 4 upon z square plus 2z plus 5. Okay, we cannot get the direct value of z here. So what we will do, z plus 4 by here z square plus 2z plus 1 plus 4. Right, instead of 5 we can write in this way. So z plus 4 upon here z plus 1 bracket square plus 2 square. So a square plus b square, but this a square plus b square in the complex form, can I write this as z plus 1 plus 2i into z plus 1 minus 2i. If you multiply this, you will get this. So is analytic everywhere. F of z is analytic everywhere except at z is equal to minus of 1 plus 2i and z is equal to minus of 1 minus 2i. Okay, are the poles of order 1, which is simple pole. तो हम लोग Cauchy's integral formula use करेंगे. So for the curved surface C, okay, so we have for the circle C, z is equal to z plus 1 minus I is equal to here. So z plus 1 minus I. So you will get here mod of z plus 1 minus I. So here z is equal to, we will take the first point minus of 1 plus 2i. Minus 1 plus 2i or minus 1 minus 2i. We will take any point here. Minus 1 minus 2i minus I. So you will get mod of minus 1 plus 3i, right? Here you will get minus of minus 1 and plus 1 is there, no? Z is equal to minus 1 minus 2i plus 1 minus I. Plus 1 minus 1 get cancel out. Here you will get mod of minus 3i and mod of minus 3i, which is equal to 3, which is greater than 2. So obviously this is mod of this is greater than 2. So hence the point z is equal to, hence the point z is equal to minus 1 minus 2i lies outside the curve C, lies outside the circle, right, outside the circle. And for second, mod of z plus 1 minus I, where mod of minus of 1 plus 2i, right, mod of minus 1 plus 2i. Plus 1 minus I. So you will get plus 1 minus 1 cancel out. So which is equal to 1 only, which is less than 2. Okay. So therefore, hence the point z is equal to minus of 1 minus 2i lies inside the circle. So by Cauchy's इंटीग्रल थ्योरम क्या हो जाएगा? कॉचीज इंटीग्रल थ्योरम से जो भी पॉइंट आउटसाइड है उसका इंटीग्रल क्या हो जाएगा? 0. ओके, सो बाय कॉचीज इंटीग्रल, यहाँ पे फॉर्मूला करते हैं क्योंकि जो इनसाइड है उसके लिए करेंगे. कॉचीज इंटीग्रल फॉर्मूला यू विल गेट जो कर्व आउटसाइड, जो पॉइंट आउटसाइड है वो हम लोग इसमें लिख लेंगे. So you will get integral over f of z upon z minus a dz is equal to 2 pi I into f of a. So integral over c, here you will get f of z is z plus 4, right? Z plus 4 upon, here you can write z square plus 2z plus 5 is equal to close integral over c z plus 4 अपॉन जो भी कर्व आउटसाइड है वो ऊपर चला जाएगा z माइनस z plus 1 plus 2i upon you will get z plus 1 minus 2i to dz. Okay, so which is equal to 2 pi I into f of z plus 4 upon z plus 1 plus 2i at z is equal to, you will get z is equal to minus 1 plus 2i. Now just put the value of z is equal to minus 1 plus 2i. So 2 pi I into z plus 4. Z is equal to minus 1 plus 2i plus 4 upon minus 1 plus 2i plus 1 plus 2i. Right? So you will get here 2 pi I into bracket 2i, 3 plus 2i upon plus 2i plus 2i, 4i plus 1 cancel out, so 4i. So ultimately you will get this. So 2 pi I or I get cancelled out. So you will get 2 pi into bracket or pi into 3 plus 2i by 2 is the final answer. I hope. Hello? Hello Jaydeep? Are you getting it? How to find out the integral by using Cauchy's integral formula. Here I explain in a very so many examples I have discussed here. How to evaluate the Cauchy's integral formula by using the Cauchy's integral formula. How to evaluate the integral. Okay. Now next is, this one is one more integral. Evaluate the integral over C 4z square plus z upon z square minus 1 into dz, where C is the curve, closed curve, mod of z minus 1 is equal to 3. Okay, here you will get mod of z minus 1 is equal to 3. So z is the, see, first of all check whether the given point lies inside the curve C or not. So what are the point of singularity here? Z square minus 1 is equal to 0. So what are the points of singularity here? What are the points of singularity? Z is equal to, yes. So the given curve f of z is analytic everywhere. Yes, z is equal to 1. Correct. So z is equal to 1 plus or minus 1. Both are there. Minus 1 square is also 1. Plus 1 square is also 1. So the given function f of z is analytic everywhere except at z is equal to minus 1 and plus 1. Okay, z square is equal to 1, so z is equal to minus 1 plus 1. Okay, so now we will check for the z is equal to 1 whether it lies inside the curve C or not. So first singularity for z is equal to minus 1 we will check. So for z is equal to minus 1, so minus 1 which is equal to mod of minus 2 which is equal to 2, and obviously this curve is like, this is a curve, circle with center at, you will get whatever the center will be x plus I by minus 1. So here x minus 1 which is a circle with center at 1 0 and radius 3. So obviously it is lies inside the curve C for z is equal to minus 1. So for z is equal to minus 1 which is less than 3, so lies inside the curve C. So this is your curve, suppose this is a circle with center at 1 0, right? So here you will get the center at 1 0 and radius 3. So 2 will be here somewhere, right? So this is the radius. So obviously the point z is equal to minus 1 lies inside the curve C, right? So here we can here z is equal to 2, so lies inside the curve C. Z is equal to minus 1 lies inside the curve C. Now check for the z is equal to 1. So 1 minus 1 which is equal to z minus 1 which is equal to 0 obviously lies inside the curve C. Both the lies inside the circle. Okay, so z is equal to 0 is also lies inside the curve C, inside curve C. So by which formula is applicable? So both the lies inside the curve C. So by Cauchy's integral formula will get, by Cauchy's integral formula we can say, by Cauchy's integral formula we get, see here you can write down integral over C 4 z square plus z. So instead of writing z square minus 1, can I write here is z plus 1 into z minus 1, so that I can apply the partial fraction here. So 1 upon, so you will get integral over C. So 1 upon z plus 1, z minus 1, 1 minus minus 1, so 1 by 2 मिलेगा यहाँ पे. So 1 by 2 a minus b. So 1 by 2 into bracket 1 upon z plus 1 minus 1 upon z minus 1. So into, which is equal to, you will get 1 by 2 into integral over C 4z square plus z upon z plus 1 dz minus 1 by 2 into bracket 4z square plus z upon z minus 1 dz. Okay, so you will get 1 by 2 into, now see z is equal to minus 1 is the singularity, so here put f of z. So a is equal to, what is your a? Here 1 by 2 into 2 pi I into f of a is equal to minus 1, right? And minus 1 by 2 into 2 pi I into f of a is equal to 1. So here your f of z is equal to 4z square plus 2. Sorry, 4z square plus z. So you will get f of a is equal to minus 1. So for a is equal to minus 1, you will get minus 1 square, that is plus 1. 4 minus 1. So you will get 3. Here f of a minus 1. So here is equal to 3. Now, so once you get this is equal to 3, for a is equal to minus 1. Now for a is equal to plus 1, right? So put a is equal to plus 1. So you will get here 1 square, that is 1 plus 1 5. So you will get here 3 and 5. So just put it here. So integral over C 4 z square 4z square upon z plus 1 into z minus 1 dz is equal to, here 1 by 2, 2 to get cancel out, pi I into 3. So 3 pi I, 3 pi I minus, here you will get 2 to get cancel out, f of 1 is 5. So 3 pi I minus 5, 5 pi I, right now, 5 and 2 to get cancelled out, minus 5 pi I. right? So you will get minus 2 pi I is the final answer. I hope you are getting it here. Okay. Is it clear how to evaluate the integral? Okay. So here 3 pi I minus 2 pi I. So minus 2 pi I is the final answer. So I hope you are clear how to evaluate the integral by using Cauchy's integral theorem and by using Cauchy's integral formula. Also, we'll see one or two examples here. Z is equal to pi by 3 raised to 4 dz, where z is equal to 2 is the circle. So z is equal to minus pi by 3. So again, z is equal to minus pi by 3 is a pole of order 4 and z is equal to 2. So obviously it lies inside the Cauchy. So by using Cauchy's integral formula, we'll get. Okay. So thank you so much. You can solve this example in the same manner, and the remaining part we will continue in the next lecture. That is tomorrow I will be coming with the Cauchy's residue theorem, how to evaluate the integral by using Cauchy's residue theorem, Lorentz series, and we will see the Taylor series also. Okay, everything we will cover and we will take any example and how to evaluate it. हम लोग यहाँ पे purposefully कर रहे हैं कि ये Cauchy's integral theorem है, Cauchy's integral formula है, तो evaluate कैसे करना है. But अगर कौन सा भी integral दिया है तो कैसे evaluate करना है, that part we will see in the next lecture. Thank you so much. Okay, if you are liking my videos, please do like, share and subscribe. Thank you so much.